Chapter 1.8.8 Role-Based Access Control Good Practices. Kubernetes RBAC is a crucial security measure that restricts cluster users and workloads to only access resources necessary for their roles. It is essential for cluster administrators to carefully design permissions to prevent privilege escalation and minimize the risk of security incidents. Adhering to best practices in RBAC, along with consulting the general RBAC documentation, can help ensure the security of Kubernetes clusters. Understanding potential areas for privilege escalation is key in maintaining a secure environment. General good practice. The text discusses best practices for ensuring the least privilege principle in Kubernetes environments. It suggests assigning minimal RBAC rights to users and service accounts, only providing permissions necessary for their tasks. General rules include assigning permissions at the namespace level, using role bindings instead of cluster role bindings for specific namespace rights, and avoiding wildcard permissions to prevent granting excessive access to all current and future object types. Administrators are advised against using cluster admin accounts, allowing low-privileged accounts with impersonation rights to avoid accidental modifications. Moreover, it recommends minimizing the distribution of privileged tokens by not assigning powerful permissions to pods unless necessary. For workloads requiring powerful permissions, limiting the number of nodes running such pods, ensuring necessary daemon sets are run with least privilege, and avoiding running powerful pods alongside untrusted ones are recommended practices. Additionally, the text highlights the importance of hardening Kubernetes security by reviewing default RBAC rights, removing system unauthenticated group bindings, and disabling the auto-mounting of service account tokens. Periodic reviews of RBAC settings are also essential to identify redundant entries and potential privilege escalations, such as the inheritance of rights from deleted user accounts. By following these guidelines, organizations can enhance security measures and minimize risks in Kubernetes environments. Kubernetes RBAC, Privilege Escalation Risks. The Kubernetes RBAC system has a number of privileges that, if granted, can allow users or service accounts to escalate their privileges within the cluster or affect systems outside of it. It is important for cluster operators to be aware of these potential risks and take necessary precautions to prevent unauthorized access. One area where caution should be exercised is in the listing of secrets. Allowing get, list, or watch access on secrets can expose their contents, potentially compromising sensitive information. Workload creation permissions can also pose a security risk, as creating pods grants access to other resources such as secrets, config maps, and persistent volumes that could be exploited to gain higher privileges. Implementing pod security standards and enforcing least privilege principles can help mitigate these risks. Granting access to create persistent volumes, especially host path volumes, can also be a security threat, as it could provide access to the host file system and potentially allow for privilege escalation. Access to the proxy subresource of nodes should be carefully controlled, as it bypasses audit logging and admission control, allowing for command execution on pods. The escalate, bind, and impersonate verbs in RBAC should be used cautiously, as they can allow users to escalate their privileges beyond what they were originally granted. Similarly, granting rights to control admission webhooks or namespace modification can lead to unintended access to resources and configurations. In summary, it is crucial for cluster operators to carefully manage RBAC privileges and only grant access to trusted users or applications. Implementing strict security measures, such as pod security standards and least privilege principles, can help prevent unauthorized access and privilege escalation within the Kubernetes cluster. Regular audits and monitoring of RBAC permissions are also recommended to ensure the security of the cluster infrastructure. Kubernetes RBAC denial of service risks. The text discusses a potential denial of service vulnerability in clusters where users have permission to create objects. This vulnerability could lead to a denial of service attack by creating large objects that overwhelm the system. This issue is particularly concerning in multi-tenant clusters where semi-trusted or untrusted users have limited access. One suggested mitigation is to implement resource quotas to limit the number of objects that can be created. An example of this vulnerability is seen in etcd used by Kubernetes, which is susceptible to an out-of-memory OOM attack. Implementing resource quotas can help prevent this type of attack.